talking a little bit with Puneet Sinha, Director Sênior Battery Industry at Siemens Digital Industries Software. The demand of battery is growing exponentially. What are the biggest challenges for large scale production, and how can this digital transformation help overcome them?
For large scale production is a big challenge for battery industry, especially not only for the startups or the new companies, but also for the companies who are doing production for many years. And the best way to explain that is think of battery cell manufacturing as cake baking. You take your ingredients, mix them in a goo, and then you spread them, and at the end you're gonna put it in a oven, and that's how you make a cake, right? Those are exactly the same steps that you use for battery cell manufacturing. But as in cake baking, just because you and I have the same recipe, it's unlikely we'll make the same quality of cake. I'm sure your cake will be more delicious than mine. And the reason is that perhaps the other person has more experience in doing that. So battery manufacturing also has been for last 25-30 years very experience driven. That means companies who have perfected or increased their production, they have they have achieved that by improving their processes through hit and trial, through experience. That freedom, if you're a new company, new startup, new joint venture getting into large scale manufacturing, you don't have 10 years to improve your battery production process. Right? But even if you are a large scale manufacturer who is doing battery production for many years, as the battery technology, battery materials change, the experience that you have used to perfect your production process may not scale. So that's why it is a big challenge on how you scale up your battery production, making sure that throughput is high and battery quality is at the right scale. One big challenge is scrap rate. When I talk to a lot of battery companies, is when they are starting their large scale production journey, many times their scrap rate is up to 40% or more. But even the companies who have large scale production often deal with 10% scrap rate, which is very high. So reducing that scrap rate needs digital technologies where they can use data to understand where is the problem and use the data to identify how to solve that issue and then put that back into the system. And that is a key example of why digitalization is a big part of industry to come to a scaling up their production.
Very good. And how is Siemens utilizing artificial intelligence and automation to improve efficiency and quality in battery manufacturing?
Absolutely great question, and we get that all the time. So as you may have seen, that from Siemens we have a strong focus on what we call industrial AI. That means how we can allow engineers to use AI that can understand the language of engineering and manufacturing, along with text and images and those modalities. So how we are looking to leverage AI for and bring that value to battery companies is what we call AI powered comprehensive digital twin. So how AI technologies can be part of our simulation suite so that companies can design their uh, battery cells leveraging power of AI, how they can use AI based innovation for new materials chemistries, and also as I mentioned in the previous example, how they can use AI when companies are looking at collecting data, trying to identify what are the problems based on that data, and AI is playing a big role in helping them manifest data driven manufacturing.
Sustainability is a critical topic in the battery industry.
Yeah.
What innovations can make production more eco friendly and reduce environment impact?
Yeah. So batteries are critical element of the equation to reduce overall carbon footprint in this world, no doubt about it. But when we look at battery production, it's a very energy intensive process. To put in perspective, many times one needs to consume around 30 units of energy to create 1 unit of battery energy. So if that means, depending on what grid energy source you are using for your battery factory and how efficient your battery production is or is not, can have a significant impact of the overall carbon footprint, especially for battery manufacturing. Also, in the battery, there are various chemistry that are used, like nickel, cobalt, manganese, and many others. Um, Many times, a lot of these chemistries have certain supply chain challenges. So it is important that we can recycle lithium
Mhm.
ion batteries to extract those materials rather than always relying on the fresh material uh, and and solve some of the supply chain issues. Recycling is still for lithium ion batteries is very low. Around only 5% of EV batteries are recycled today. Put it in perspective, for lead acid batteries, close to 95% or higher. So there is a long way to go for lithium ion batteries to be recycled in a scaled, cost effective way. So these are all the parts of sustainability challenges. But from when we look at sustainability challenge from Siemens perspective, we do not look at sustainability as an add-on that you do separately. For us, sustainability is part of the life of battery, how it is designed, how it is manufactured, how to be used, and of course, how you can improve the efficiency of recycling. So we are using digital solutions, and companies are using Siemens comprehensive digital twin so that they can optimize the batteries using less prototypes, optimize the amount of material they have to use so they are not over engineering those batteries. And when they are producing those batteries, how they can optimize the overall plant energy consumption to put it. And they are using our solutions like Technomatics, like our ITOT
Mhm.
integration solutions. And to give put in perspective, a company called HCM is an example, a great example. They make battery materials by leveraging our solutions, and they were able to explore and optimize their process in digital world
Mhm.
and then manifest that in the real factory, and they were able to reduce energy consumption by 5%. An example of how these digital technologies and digital twins that Siemens brings can help optimize and reduce energy consumption. And all of these things play a role in making batteries more sustainable. And also, of course, recycling side, we have solutions and we are working with companies how the recycling efficiencies can be improved.
Do you believe that advancements in digital twins and the industrial metaverse can accelerate the development of new energy storage technologies?
Absolutely. The way we look at it, AI, industrial metaverse, they are critical part of taking the battery industry to the next level. As I said, new technologies are coming from materials level to the new pack architectures, new applications, not only EVs, but energy storage. And of course, companies are also expanding their operations in different countries, their regulatory compliance issues to achieve, to meet all of those challenges while making sure the batteries are safe, they are and cost effective. It is critical that companies continue to leverage, and we are in our conversation we always say companies are very excited and interested how they can use AI or also industrial metaverse. One example for metaverse is when a company who's, let's say, operating and have a strong profitable operation in Asia, if they are looking to expand their footprint in another country, creating that factory blueprint and taking that experience to a new country is a big challenge. In that case, they are looking at our industrial metaverse solutions and say, how can they use industrial metaverse to create a blueprint of the factory that they can go put at the new place, and also use it to train their workforce. It's a new workforce, how they can leverage industrial metaverse to train those workers as well. So that's an example of among many that companies are very excited in the battery ecosystem to use our metaverse. We have customers using metaverse, and with the power of AI, with the power of low code, uh, and complementing the combination of digital twin and generative AI and data, industrial metaverse is key to how the next generation of workforce is going to do the things and build new products.
Thank you so much.